Hello, hi, my name is Armando Martinez, and today I'm gonna be making the reflection for the last model. Sadly, it's the last model, the end of the class. And for firstly, for prompt one, which is understanding machine bias. So basically, what is machine bias? Well, in my own words, I would say machine bias is when an algorithm systematically treats some group of people unfairly, not because the math is evil, but because human biases, give data, and social inequalities have been baked into how the model is built, trained, and used. Cathy O'Neill's would call many of these systems weapons of math destruction, which are basically models that are opaque, scalable, and harmful, and then tend to reinforce existing inequalities rather than reduce it. And well, basically, the two ways machine bias shows up in real life. The first one I would say, one idea that comes up is criminal justice and policing. Well, firstly, risk scoring tools predict who is likely to reoffend and are used to set bail or sentences. Studies have shown that these systems can label black defendants as high risk more often than white defendants with similar records because they're trained on historical data from a justice system that already policies some communities more heavily. And while O'Neill argues that these models can create feedback loops, more police in poor neighborhoods, more arrests, data that proves the neighborhood is dangerous, harsher risk scores for the people who live in there. And while the second way uh, machine bias can come up is in education and employment. So O'Neill also discusses teacher value added models and hiring algorithms. Teacher models try to rank teachers based on test scores changes, but in practice behaves almost like random number generators, costing some teachers their jobs. Similarly, resume screening systems learn from historical hiring decisions. If a company mostly hired men from certain schools, the model learns that profile as ideal and downgrades everyone else, embedding gender and class biases into automatic hiring. Well, broader social implications. This would be, for example, machine bias matters because these systems are invisible, hard to challenge, and have high stakes. O'Neill's core argument is that they tend to target those with the least power, the poor, racial minorities, and other marginalized groups, and they can amplify inequalities at scale while still being marked as objective and scientific. Going to prompt two, the real world case studies. Well, firstly, I found this article called The Dutch Childcare Benefit Scandal, an urgent wake up call to ban racist algorithms. It was published on the 25th of October of 2021. So basically, what happened and who was affected. The Dutch Tax and Customs Administration used an algorithm to flag risky application for childcare benefits. The system treated things like nationalities or risk factors, so non-Dutch or dual nationality parents were most likely to be flagged as potential fraudsters. Amnesty reports that tens of thousands of mostly low-income parents and caregivers were falsely accused of fraud. Many were forced to repay large sums and leading to debt, unemployment, evictions, and family breakdown. So one key short quote that I gathered from this article was tens of thousands of parents and caregivers from mostly low-income families were falsely accused of fraud by the Dutch tax authorities. Another striking quote was thousands of lives were ruined by a disgraceful process which included a xenophobic algorithm based on racial profiling. And some technical factor behind the harm was biased features in the models, self-learning feedback loops, opacity and lack of explanations, and no effective accuracy or fairness checks. Moving on, we have the social and institutional factors. Firstly, institutional racism and xenophobia. Amnesty describes the system as xenophobic and built around racial profiling. It reflects pre-existing stereotypes linking migration and welfare fraud, which were then encoded in policy and code. Then we have pressure to fight fraud and prove efficiency. The tax authority had a perverse incentive to show that the algorithm was effective at catching fraud, which encouraged aggressive recovery actions regardless of how many innocent families were harmed. Third, we have the lack of oversight and redress. Families couldn't get clear answers about what they had gone wrong and how to contest the system. Oversight mechanisms for algorithm systems in the public sector were weak or non-existent. In short, this is a classic social technical failure. Past design choices, opaque machine learning, and existing power imbalances in the welfare system all combined to produce large-scale harm. Lastly, we're in the prompt number 3, which is connecting theory to practice. Well, how does this example illustrate O'Neill arguments? So, Cathy O'Neill defines weapons of mass destruction as the algorithms that are opaque, scalable, harmful, or unjust. And the Dutch childcare benefit algorithm fits this perfectly because it's opaque because parents and even civil servants didn't know why someone was flagged as high risk. The system was a classic black box. Then it's scalable because it was an applied nationwide to all childcare benefit applicants, and it was harmful to vulnerable people as it targeted mostly low-income, ethnic minorities, and migrant families, that the exact groups O'Neill warned are most at risk. And so vulnerable groups harmed and how. So low-income families were pushed into debt, unemployment, and even homelessness when benefits were cut and large repayments were demanded. Ethnic minorities and non-Dutch or dual nationality parents were disproportionately targeted because nationality was explicitly used as a risk factor. The harm was not just financial. Amnesty notes mental problems, divorces, and family breakdowns. Lastly, we have the strategies to ensure fairness in machine learning development. Strategy 1 is mandatory impact and fairness assessment before deployment. Run human rights and fairness impact assessment before deploying any high-stakes model in government. For example, we can evaluate error rates based subgroup, whether protected attributes are being used directly or via proxies, and the severity of consequences in the model is wrong. Strategy number 2 would be transparency, explainability, and appeal mechanisms. They will publish model cards and documents explaining what data was used, what the model is supposed to do, known limitations, and fairness evaluations. The last strategy would be strong governance and bans on certain uses. Lastly, we have the building representative datasets for diverse populations. Firstly, we define the target population and task carefully. Second, we detect and correct representative biases. And thirdly, we use exclusive sampling and target data collection. Fourthly, document datasets and monitor over time. So this is basically my reflection for this model, and it has been a great pleasure to learn and to not only learn about how to use data science, but the ethics of it, how to use it correctly. Thank you very much and have a great day.